Hello Khan Academy, this is Will Humphrey, and I will be presenting you a two-part problem on calculating molar solubility. The first part of the problem is calculating the molar solubility of silver bromide in water. The first step is to set up your equation. Here we have solid silver bromide in equilibrium with its two ions. We can calculate the molar solubility of each ion because we know that the KSP, or solubility constant, of silver bromide is equal to the concentrations of the ions multiplied by each other. Therefore, the concentration of Ag plus and Br minus is equal to 7.7 times 10 to the negative 13th. Doing that math out, you get that S squared is equal to 7.7 times 10 to the negative 13th, or S is equal to the square root of 7.7 times 10 to the negative 13th, giving you a value for the molar solubility that is 8.8 times 10 to the negative 7th moles per liter. The second part of this problem involved calculating the molar solubility of silver bromide in a 0.25 molarity solution of NH3, ammonia. The silver ion is reacting with 2 moles of ammonia to produce a complex that is silver and 2 ammonia groups. This calculation is a little more complicated because there's 2 parts we have to work with. We are given the Kf of AgNH3 2 as well as the KSP of AgBr. When we write out the equation for the Kf, or formation constant, of AgNH3 we get that it is the concentration of AgNH3 the product, over the concentration of the reactants, the Ag plus ion as well as the ammonia ion. That value is squared because there is 2 moles in the equation. Because the Kf is equal to 1.7 times 10 to the negative 7th, we set the entire equation equal to that value. It is important to note that that value of Kf is enormous. What it means is that almost every single Ag plus ion is transformed into the AgNH3 complex. This will come into play later. Now remember that the KSP, or solubility constant, of AgBr is equal to the concentrations of the Ag plus ion and the Br minus ion. To get K, or the concentration constant in whole, you multiply the solubility constant by the formation constant. Therefore, K is equal to AgNH3 plus over the concentrations of the silver ion and the ammonium molecules squared, multiplied by the concentration of silver ions times the concentration of bromine ions. The 2 silver ions cancel out. Now thinking back to that huge Kf, what that tells us is that because almost every single Ag plus ion is transformed into the AgNH3 complex, the concentration of Br minus ions is just about equivalent to the concentration of AgNH3 Therefore, in this equation, after the silver ions cancel out, and we multiply NH3 squared by K, we have 2 identical concentrations, both S. K, if you remember, is equivalent to the KSP, the solubility constant, times the formation constant, times the concentration of ammonia ions squared. This is equal to the concentration of AgNH3 times the concentration of bromide ions. Expanding this equation, we get the values of KSP, of Kf, and the concentration of NH3 equal to S squared. S squared is equal to 8.2 times 10 to the negative 7th, and taking the square root of that, we have our molar solubility of AgBr in a 0.25 molarity solution of ammonia. Thank you.